So as we're learning with these double integrals, setup is the key because half the time we make Maple do some of the integration for us. So it's important that we learn how to set up our integrals, even if we're not going to evaluate them. All right, so let's do that for these examples. So we want to set up the integral to find the double integral over the region f of x, y, dA, but not evaluate it, where R is the rectangle with vertices 0, 0, 0, 3, and 4, 2. Okay, so 0, 0 is right here, right? There's 0, 0, the origin. 0, 3 is up here. 4, 2 would be out here. So our region is that triangle in that zone. Now the question becomes, how would you set this up? You don't want to do a horizontal rectangle, because if you did a horizontal rectangle, you would go from the y-axis out to this line for part of it, and then the y-axis out to this line for part of it. Those are two different lines. So you'd have to set up two sets of double integrals. No, no, no. We want to do a vertical rectangle that goes from one line to the other line. So that's what we're going to do. Okay, so our double integral will be of this function, f of x, y. Okay, so when we do this, this is dx right here, right? So we're establishing that dx will be our back value and dy will be our front value, right? That's what's happening when we chose a vertical rectangle like that. Okay, so y is going to go from this function down here to this function up here. So we're going to need to find those equations. But those are diagonal lines. We learned how to find the equation of a line back in Algebra 1. This is y equals rise over run, so 2 over 4x, or in other words, y equals 1/2 x. So that's the bottom, right here. Y equals 1/2 x, up until y equals, all right, this one's going to be a little trickier. It's 3 is our y-intercept. And then we're going down 1, because 3 to 2 is 1, over 4. So it's negative 1/4 x plus 3. So this is y equals negative 1/4 x plus 3. That's the bottom. This is the top of that rectangle. And then the rectangle ranges from x equals 0 over here all the way to x equals 4 over here. All right, let's do it again. So now we're going to find the region inside x squared plus y squared equals 25 and to the right of y equals negative 3x plus 5. Okay, this is a circle of radius 5. So we're going to draw a circle as best we can of radius 5. All right, and now negative 3x plus 5, that means it has a y-intercept of 5. So that means that we're going to be coming along a diagonal line from up here to down here. So this is y equals negative 3x plus 5. And the region is inside that circle, but to the right of that line. So that's right here. Okay, now circles are a little tricky because we want to deal with circles, but they're not functions in terms of y or x. So they can be a little dicey. So you have to think about it. If you wanted to go vertical, the problem that you'd have with a vertical equation is that you'd be y equals for the top half and y equals for the bottom half. So you'd have to do two separate systems of double integrals to do that. So you're better off with a horizontal rectangle on this one. And so that means dy will be our back integral. So we're going to have a double integral of our function, and it's definitely going to be dy in the back and dx in the front. I'll just put dx right here. Now to do this, I'm going to need a couple things. I need to know when these two equations are equal to each other. So I need to know when this hits right here. Obviously it hits at 0, 5. So I know my top number for y is going to be 5. No problem, right there. But what's this bottom number? So I'm going to have to um, solve it, or I could use maple. I've got to figure out a way to figure out where this is. All right, so I just put in the solve command, and I said solve this system with the equation for the circle and the equation for the line, solve it for x and y, and I can see that y equals -4 and y equals 5. All right, so that will get me my -4 value over here. So this down here would be 3 comma -4 found with maple. All right, so -4 is the y value. So I'm going to do that. And again, I'm doing this, you're about to see why actually. It's because of the function for the side of the circle. I can actually solve this circle for just this right half. The right half would be x equals the square root of 25 minus y squared. Right? If you solve this for x, the negative square root would be on the left, the positive square root is on the right. And that's why I'm choosing that, because if I can get this whole region with just one function, then the right side would just be that function. So I can put that in right here. So this is the square root of 25 minus y squared. The left is equal to this line, but solved for the other variable. So this is no good to me. I can't just go stick -3x plus 5 in here. I need it to be solved for x. These have to be x equals values. All right, so we have to go over here and solve that. So if y equals -3x plus 5, y minus 5 equals -3x. So x equals y minus 5 divided by -3. That's the left. So this would be y minus 5 divided by -3. There's the setup. It's key that you match your variables with your differentials. So if this is dx, that means this is the left and this is the right. And you have to have them solved for x. That's key. So x equals some function of y, x equals some function of y. And then y has to be constants. You have to have your last integration with constants. And again, I went horizontally because vertically would have actually been two separate square root equations, which is much harder to do than what we have here. Right? This is easier to go horizontal than it was to go vertically. So you have to know your algebra pretty well to know which way is the easier way to do this. All right, last one on this one. What about y equals the absolute value of x, which we all know looks like a giant V, right? There's y equals, and y equals 4. Y equals 4 is right here. So y equals the absolute value of x is right here. Well, for starters, I don't know an easy way to come up with a solution for this in terms of x, so I'm betting we're going to go dy dx, and we are. So this is f of x comma y, and we're going to go back to the original. We're going to go dy dx. Now, where is x going to be? X is going to be right here. So the absolute value of x is equal to 4, means x equals -4 or +4. So my x values are -4 and +4. Oh, and my region, I should have shaded it. Sorry. It's right here. That's my region. And then I'm obviously doing a vertical rectangle on this case because I'm going dy dx. It might help you to kind of write for yourself. dy dx is vertical rectangles, right? These are vertical rectangles, approximating rectangles. And then dx dy is horizontal. All right. So then what are my y values going from? Well, in this case, it's pretty easy. From the low part, which was the absolute value of x, to the high part, which is 4. Right? This is the low, or the bottom, if you will, of that region, and this is the top. And again, these are y values. You don't actually have to write the y equals in, but I find that it helps when you're first learning how to do these integrals to write it in, to remind yourself what variable you're working with.